Welcome to Lesson 12, Geometry fans. This is part one of the lesson, Pythagoras and the structure of the universe. This is the island of Samos, where Pythagoras lived. It looks pretty much today the way it did back when he lived 500 BC. Pythagoras was a tremendous philosopher and a mathematician. He proved that both acoustics and optics were mathematical, and that was way back in 500 BC. But he also understood, as he looked out over his island, like we're looking out over this bay in the island today, that all of the geography was ruled by gravity in the vertical and by the horizon in the horizontal, and that those two things had a perfect right angle between them. Here in this picture, an aerial of the beautiful island of Samos, Pythagoras could look out directly to the north toward the Hellespont, and when he turned 90 degrees to his right, he looked toward modern-day Turkey, held by Greece at the time. Another 90-degree turn, he looked out south over the Mediterranean. A third, he would look west toward the island of Crete and southern Greece. 90 degrees more, and he was facing north again. This, again, was a set of turns, 4, that resulted from 90 degrees each. The ancient Babylonians and the ancient Indians in India and the ancient Egyptians all understood that if you had a triangle with sides of 3, 4, and 5, that it would give you a perfect right angle between sides 4 and 3. They understood this, and they used it for construction, which was really important, because if you were going to put up an obelisk 3,000 years ago, like this one you're seeing here, with the buildings next to it that are equally as old, you wanted them to stay standing up. If they fell down, it could go bad for you. But what Pythagoras discovered was more than you could just make things upright. He discovered in a 3, 4, 5 triangle, if you took the 5 side and squared it, 5 times 5, it gave you 25, like the tiles shown here. And that the other two sides, the side with the 4 became 16, and 3, of course, became 9, but that 16 and 9 added up to exactly 25. In other words, the literal squares of the two sides were equal to the square of the hypotenuse. This was an astounding discovery, and it developed into what has become the Pythagorean theorem, the single most important equation in all of mathematics. You can see here, all he did was make a simple observation, but nobody else had realized this. What he also realized is that this particular formula, the two sides that were shorter adding up to the square of the hypotenuse, would happen no matter what kind of triangle side lengths you had, as long as a perfect right angle. Of course, 3, 4, and 5 triangle will give you a right angle, and so will a 5, 12, 13, and also a 7, 24, 25, or any multiples of those. Students who study geometry should know these 3 sets and memorize them. There's a trick for doing that. The first 3 are consecutive. There's also consecutive numbers in the next 2. And the short sides increase in each case 2. So there it is, Pythagorean theorem. We can use this to find the side of a right triangle if we have 2 of the other sides. We only need 2. of any two sides to find out the whole formula, normally expressed as a squared plus b squared is equal to c squared. If we have b squared, we can find a squared by subtracting it from c squared. The same with a squared if b squared is missing. That's it, folks. Enjoy.